In today's video, we will go over an identity known as king property. Essentially, it's this equation here. The integral of f of x from a to b equals the integral of f a plus b minus x from a to b. This identity is useful when a reflected version of the function makes the integral simpler or gives another form that can be used to simplify the original equation. Let's first start by proving this identity algebraically. Doing this is actually pretty simple. First, let's set x equals a plus b minus t. So dx equals minus dt. Next, because this is a definite integral, we need to redefine its domain. So if we substitute x equals a, the a's cancel and we end up with t equals b. Likewise, if we substitute x equals b, the b's cancel and we end up with t equals a. So let's rewrite this integral in terms of t. Substituting x equals a plus b minus t, dx equals minus dt, and changing the domain from a to b to a gives us the integral of f a plus b minus t times minus b dt in the domain b to a. Recall that an integral in the domain b to a is simply the negative of an integral in the domain a to b. Therefore, this integral can be simplified further to give the integral of f a plus b minus t dt from a to b. And so, our proof is complete. Let's move on to a visual illustration of what this means. Let's say this is some function f of x. The area of the shaded part in blue is equivalent to the integral of f of x from a to b. Now, let me sort of expand the domain of this graph to negative. And then consider what the graph of f a plus b minus x means on the same graph. If you recall, changing what's inside the parenthesis of the function either translates, stretches, or reflects the curve. For simplicity purposes, first let's consider the graph of f a plus b plus x. This is simply a translation a plus b to the left. What this means is, what used to be on b will move negative a plus b, or to negative a, and what used to be on a will likewise move negative a plus b, or to negative b. Let me sketch this curve using red and label the graph. Now let's consider the graph f of a plus b minus x. This is simple. It's a reflection of the red curve along the y-axis. Let's draw that with blue and shade that section. And so what you end up with is a reflected version of f of x in the domain a to b, with its center of reflection at a plus b all over 2. Alright, now that we understand the property and what this is really doing, let's try an example. This is a question directly from a put-in practice document in the calculus section. Find the value for the integral of the natural log of 3 plus x over the natural log of 3 plus x plus the natural log of 9 minus x dx from 2 to 4. Let's start off by using the king property and replace all of x with 2 plus 4 minus x, or in other words, 6 minus x. And simplify. Doing this will give us the integral of the natural log of 9 minus x all over the natural log of 9 minus x plus the natural log of 3 plus x dx from 2 to 4. And what you can notice is that after this substitution, the denominator hasn't changed, but the numerator has. These integrals are both equal to I, so let's add the two. The denominator is the natural log of 9 minus x plus the natural log of 3 plus x, and the numerator is also the natural log of 9 minus x plus the natural log of 3 plus x. And this integral is equal to 2i. And so the numerator and denominator cancel out with each other and leaves us the integral of dx from 2 to 4. This is a very simple integral and simplifies to x. Substituting in 2 and 4 gives us 4 minus 2 equals 2, and this is equal to 2i. Therefore, dividing both sides by 2, the value of this integral is 1. And that's all for today. Thanks for watching.